radiation testing and thermal testing and so forth to show that they will be working good.
But you still got to move those electrons around.
Well, the -40 doesn't slow those up too much, but the problem with commercial parts is that nobody really designs them to work below, you know, -40 and 50.
Yeah.
So we're kind of stuck with that. But that turned out not to be a big problem, again, with all the waste heat the RTG is giving off, so.
It's not wasted. It's used.
Yes, it's really actually quite good. So, give me the next one, Roger. So we'll have this whole set of cameras, and this is going to let us, these are all pictures from Mars, actually, except for this one, which is a lab test, but quite representative. For the panoramic cameras, we'll shoot panoramas all around the rover, see, at least certainly initially, when we land, we'll see dunes. We have the cameras in the front looking forward and seeing what's for us, the cameras looking down at the sample collection area to see what's going on there. And then we'll have these microscopic cameras that are focused on where the drill will be pointed that actually will resolve sand grain sized particles.
What's the drill? Titanium?
I think so, but I just have to ask that. Again, not my department.
You said proto.
They have done a huge amount of developmental testing on that, though, drilling into everything from concrete to plaster of Paris to water ice and liquid nitrogen temperature. So it's obviously it's a fairly critical thing because they can't collect the sample, they can't do the mass spec work, and it was kind of a long trip for nothing.
So there's only one drill.
There's actually redundancy with that too. So that the vehicle is actually kind of like life on Earth. It's just bilaterally symmetric, and we've got two of each camera on each side. And on each side, there's two of these drills with two of our microscopic cameras focused on where they actually do the drilling.
The Chinese drill that got stuck on the moon, was that double or single?
I don't think it was double.
Yeah, I don't know. But and they never got unstuck, did they?
Not that I've heard.
They've gone silent.
But drilling is a problem. Also, the Germans had a problem with their heat flow measurement on InSight. They were supposed to put something down a couple of meters to measure the thermal gradient heat flow, and they hit a rock or something. So that seems to be not looking too good right now.
Yeah, just like the virus.
Yeah, you gotta.
What's the launch mission cost at launch?
I believe all these New Frontier things, the cost cap is like, I think it's like $850 million, not counting the launch, because the way NASA bookkeeps it, they take care of the launch. They don't want individual PIs going out and buying rockets from Elon or something like that. Messing with the bureaucracy.
So it's less than $1 billion.
It's less than $1 billion, but if you put the launch in, it's probably $1 billion, so it's $1 billion mission.
So it's the same as Far Horizons, New Horizons.
Yeah. So it's got, for a mission like that, NASA really expects that it's going to work, and so the whole full redundancy is one of the things they like to see. So anyway, this is just a cartoon that the folks at APL put together showing what the whole sequence is. And it's really, really cool, and we're very excited about it, and it's really, really awesome. And the only thing that I feel a little apologetic about is that, none of this is actually going to happen until 2034, so you're going to have to kind of bear with us a little bit.
Don't die.
Yeah, well, that's going to be my plan anyway.
Yeah.
That's my plan too, but I think I'm over it.
How much faith do you have in the Gimbals who've got to turn those rotors to navigate?
Well, all I can say is that it's going to get a huge amount of attention. There's going to be testing done in chambers at tight ambient conditions with enough hours on them to pass a fair amount of skepticism. I think you can imagine that there are parts of NASA that have a lot of skepticism to this, and they're not going to let these people off the hook until they're satisfied. So I think that's it.
So a lot of this, I think, is intended to explore the chemistry of this planet, but how much is the chemistry of the planet limited by the extreme cold? I mean, applying heat is a very common way to generate reactions, and you don't have heat.
Oh Well, yeah, so the chemistry is different than it is on Earth,
Very.
but it's not absolute zero. There is chemistry going on. It's just, it's completely different. That's why I think it's so interesting about Titan. The ways that it is actually the same as the Earth, but then it's a completely different regime. It's a couple hundred degrees colder. The fluids are different. The chemistry in detail is different, but it does have some commonality with what probably went on Earth a long time ago.
So how convincing is the idea that it's possible to have slow-mo life in this environment? It's had 4 billion years of work on it.
Since this is your specialty of bringing these ideas kind of up, I mean, I think that's one of those things that you could have a discussion about. I think it's one of those things that's far enough outside the current, framework they're operating that, nobody talks about it out loud too much. So, I mean, I would like to think that if there was something like that there would be evidence of. I mean, what do you do? We'll take a mass spec, we'll take cameras, we'll take microscopic
There might be
cameras.
a morphology.
So we'd see it in pictures, we could see it in the chemistry, so I think we're taking the things we need to take if it were there, but they're certainly not suggesting that anybody entertain the idea that there might be some kind of completely alternate chemistry going on in liquid ethane that was like life.
The last chapter of a novel called If the Stars Are Gods, it occurs on Titan, watching the morphology of simple life around ponds. It was published in 1975. So.
Well, it's like I said about the lurker thing, I don't think so, but I would be happy to be involved in finding it. I mean, that would really be awesome. That'd be great.
How contained is the plutonium so that you don't crash it and irradiate any kind of
Yeah, well, the real concern about that is not Titan, it's Florida. And the thing I learned when I worked on the losing New Horizons Pluto mission is one of the things they put in the budgets of any mission that's got one of these things in it is money for the lawyers.
Yes.
Because they will be sued and they have to defend against the lawsuit, and that's in the budget because it's understood that's what's going to happen. The plutonium is in a fairly complicated cask that is designed to take some fairly substantial abuse and not come apart. So for instance, it is designed to survive having the launch vehicle blow up, so that if it did do that, they would send somebody out with a ship and they would find it on the bottom and they'd bring it up, but it wouldn't spew little pieces of plutonium all over.
It's the same protocol they use on Cassini.
Yeah. Same.
And as always, it's actually cheaper to solve a problem with automatic weapons than with lawyers.
I think I won't suggest that to them.
Mike?
Yes.
Actually, one thing I was just thinking about, coming back to your question about the fact the temperature is so low, and that's certainly true, but there's an additional energy source for things in the upper atmosphere, which is the fact that Titan is well inside the magnetosphere of Saturn, very strong. And in fact, the average temperature, there's relatively few charged particles coming out of Saturn, but their average temperature is on the order of tens of millions of Kelvin. And so there's lots of energy in those, and that actually helps to catalyze reactions in the upper atmosphere. But then percolates its way down. So that's a different source of energy.
And actually, the bigger power source is just cosmic rays.
Yeah.
The other thing, as I showed in my cross-section before, if you go deep enough on Titan, it's pretty clear that it's liquid water. It's warm enough for there to be liquid water. So this is a situation like Europa, where there is some kind of huge subsurface ocean. Now, the thinking is that the crust on Titan is much, much thicker than it is on Europa. So there's water down there, but it's, maybe a couple hundred kilometers. But there's an ocean bigger than the Earth's ocean down there. There's at least energy from, tidal flexing from Saturn. So could there be something down there? We're not going to figure that out from this, but
There could be cracks that deep, called canyons.
yeah.
I've seen titanium version of Arne Saknussemm actually go down into it.
Yeah. Well, they're looking at that for Europa because you can see the cracks.
Of course.
Yeah. Yes, sir.
Would you anticipate that, because you are going beyond your landing point and then coming back, kind of thing. Do you think there's gonna be some flybys over the lakes if you just happen to get near one? I guess you're landing in a crater, so you're not actually gonna be near the lakes, but.
I don't actually, that's a really good question. I don't know actually what the nearest sizable body of water is. I think that,
Or hydrocarbon.
yeah, sorry.
Yeah.
Yes. What the nearest lake is, I think it's not very close. Because the thing is nuclear powered and because the half-life of plutonium-238 is like 80 years or something like that. If nothing breaks, it could go a long time. I mean, Curiosity was designed to last for 2 years, and it's on its 7.5 year now. And if this lasted, proportionally as long, we could make it a long ways and do some interesting things. The way the thinking goes with these proposals is that there's a real strong bureaucratic incentive not to overpromise, because then if you don't deliver, then you are a failure, and failure is bad. So they tend to, undersell it initially and then look like heroes because they did more than they said they were going to do.
Yeah, but this is such a long time that the people planning this will be retired.
Well, some of them anyway. I'm hoping not all of them.
We also live
Yes.
That caption, how far chemistry has progressed, that statement sort of implies that Earth went through something. What's the current state of affairs? Did Earth go through a Titan-like phase, or are we just studying chemical processes that matter?
It's never that cold.
It's never that cold. I think the thinking is just more an environment. There was an environment on Earth where there was not a lot of free oxygen. It was more reducing, so that kind of thing, and that the chemistry that you would find in that environment, obviously it was never that cold. So, but it also, I now that you point that out, I note that does kind of leave the door open to Gregory's, liquid ethane pond scum going on there. Like, I think they're open to finding it if it is there.
Oh, they would found the term scum insulting.
I'll have to look up and remind myself what you called it.
What species is this?
Sorry. Any other questions? Oh, sorry. Yes.
So, so the skids, are they going to limit where it can land, and will that limit the science?
Certainly, yes. I think a key part of every time they get the pictures down and they decide what's going to be a good landing site, it's like, if it's too rough, for instance, if it's really rocky, such that the skids would, potentially tip the vehicle over something, they'll stay away from that stuff. So I think that will definitely limit the places it can land. But I think, based on what we have seen, certainly in the orbital data, that doesn't seem like an onerous. I think we can learn plenty, even not landing every place we might want to land. I think that's definitely true.
It seemed to work okay.
Is it near the equator?
Yeah, it's actually pretty close to there, which is the sort of disappointing thing from the lake standpoint, because all the big lakes are up near the poles.
Right.
So, yes.
How stable is the landscape? Are there Titan quakes of any sort, magnetic quakes, or?
Well, I think the short answer is we don't know.
Yeah.
One of the sort of ancillary, more speculative instruments we're taking is mounted on the skid. There are sensors for seismometers, so if there are certainly large quakes going on, we'll have the opportunity to sense them. It's not like we see lots of, extensive evidence of landslides everywhere that would indicate that things are shaking all the time. But it is, tightly locked with Saturn, and I'm sure it's that outer ice shell on the liquid water shell is flexing all the time, so there's plenty of energy being pumped in there to do stuff like that. So I don't think we'll be surprised if we actually do detect quakes. But certainly hoping that they're not bad enough that the thing, is falling over just when it's sitting in the ground.
How tall is it?
Sorry, I'm trying to remember when I was standing next to the test bed rover for Curiosity. I think if you stood next to it, the upper deck would kind of be about chest high.
So it's less than 2 meters.
Yeah, yeah. I think the cameras on the high gain antenna are probably about 2 meters off the surface. So.
It's a flying box.
Is there a correction mechanism? I mean, I'm trying to figure out if it hits a wind and flips, if it's coming in and it flips over.
Well, this is the thing where we're profiting off all of the work that's been done on drones over the last decade, which is, it's a completely different flight regime. It's very software. It's very active. I have my 8 props, and I'm making millisecond by millisecond decisions about how to drive them to keep the vehicle stable, because it's as Gregory said, it's a box. It ain't no airplane. It's like if you turn the props off, it's going to drop like a rock.
Well, it doesn't. In other words, it doesn't look like it could take off upside down.
No.
But in a sense, you have the advantage because gravity is less, that any of that tipping process will be slowed down.
Yes, and that's a big benefit.
So
certainly, yeah.
any software that can handle tipping on Earth will have no problem in tight.
Yeah.
Yes, sir.
Along those lines then with the, I guess helicopters have a thing where, even if the engine dies, the, props will
auto
go around, so
gyro,
it controls the crash.
Drones don't do that. No, if one of the props freezes up, or if multiple props freezes up, it's gonna drop like a rock.
How many are there props? 4?
There's 8, because they're sorry.
So-
Can't see,
Double stack.
Yeah, there's 2 pylons on each side, and each one has an upper and lower prop. So there is redundancy there.
Do those counter rotate? Do you know?
I believe so.
They would
Okay,
have
makes
to.
sense, yeah.
They've got to. But you could lose several, probably.
And I'm expecting that's the case, but we got that for discussions. Was there any other question? Oh.
I have an unrelated question. Dr. Rahim, does your company do cameras for other kinds of applications besides NASA?
We build cameras for customers besides NASA. I don't know what a bunch of them are because they won't tell us, but I'm pretty sure they fly them in space, because nobody would pay that much money for a camera if they weren't flying it in space. But so I don't have a security clearance. I don't actually know.
Do you have a business card that I could take away?
Certainly, yes. Just see afterwards.
She's actually from NSA.
Okay.
No, I work for General Atomics.
I see.
And we do some applications that use very high-end cameras.
Very interested in giving you a business card. Very interested.
Do you have any indication you do things for NSA? Not the NSA.
He'd tell you.
NSA.
Let's see. Am I going to get in trouble for saying this? I think that there's always at least one level of larger contractor between us and whoever the ultimate customer is. So I would literally not be able to know that. That information would never flow down to me. So
So you have plausible deniability.
actual deniability. Anyway, I think the shepherd's crook came out, so I think I'm supposed to stop talking now. Anyway, thank you all.